So in this particular example, it says, write the sine of angle D as a fraction and as a decimal rounded to the nearest thousandth. So again, if we remember SOHCAHTOA, S-O-H means sine, opposite, over hypotenuse. So I have sine of angle D. Angle D is right here. I need to label what is opposite, what is hypotenuse, and what is the adjacent. Again, longest side length, and across from the 90-degree angle, the distance from D to F, that's my hypotenuse. Then the side length that does not touch the angle that I'm talking about, so side length 16 is opposite, and 30 is going to be my adjacent. So if I'm talking about sine of angle D, then I'm looking at opposite over hypotenuse, which in this case for us is 16 over 34. So if I plug this number 16 over 34 into the calculator, it comes up as 0.470588 and a whole bunch of other numbers after that. But it told me up here to write it as a decimal rounded to the nearest thousandth, so I'm going to say that it's equal to 0.471. So these two are my final answers. And now in looking at this example, it states, using the same triangle, this time we're going to write the cosine of angle D as a fraction, then as a decimal rounded to the nearest thousandth. So I'm still going from angle D. I knew in the previous problem this was my hypotenuse. I knew the side across was opposite, and this 30 was adjacent. And again, using SOHCAHTOA, I have CAH, C-A-H, where this is cosine is equal to adjacent over hypotenuse. And I'm going from cosine of angle D, again, adjacent over hypotenuse. And in this problem, we knew that adjacent was 30 and the hypotenuse was 34. So again, plugging that into my calculator, I get 0.8823 yada yada yada, a whole bunch of other numbers, and rounding it to the nearest thousandth, I'm going to say that cosine of angle D is equal to 0.882. So both of these are now my final answer. So we're going to use the same rules that we did in 18.1 when finding the trig ratios using the tangent function. So this time we're going to use sine and cosine, and if you remember from the video that you guys watched in the real world video, they had stated something called SOHCAHTOA, okay, where so is sine equals opposite over hypotenuse, cosine was adjacent over hypotenuse, and tangent was opposite over adjacent. So if we keep these in mind, and if we don't have them in our notes already, we better put them in our notes. But if we keep these in mind, we can do, or we can find any angle by using these trig ratios. So let's say I was talking about sine of angle A. So here's angle A, and I want to know what is sine of angle A. what is that equal to? So again, like the tangent function, I need to label what is my hypotenuse, what is my opposite, and what is my adjacent side. And remember, my hypotenuse is across from the 90-degree angle, and it's also my longest side. So I'm going to say that the side length from A to B is my hypotenuse. Then the side length that does not touch angle A, so this side length from C to B, notice that that length does not touch angle A, it's opposite the angle, so we say this is opposite. And over here from A to C is adjacent. So there I have my sides made up. So if this was, let's say this was a 3, 4, 5 triangle, then sine of angle A is going to be opposite, we know is 3, over the hypotenuse, which is 5. Then again, if I wanted cosine of angle A, I would state that it is adjacent, which is 4, over the hypotenuse, which is 5. Well, let's say I wasn't going from angle A. What is going to happen? Well, it just means that I need to look at whatever angle I'm talking about, and in this case, let's say I was talking about angle B. Let's say I was going from angle B. Now if you notice, my adjacent and hypotenuse, or my adjacent and opposite are going to switch. So now the 4 is going to become opposite and my 3 is going to become the adjacent. Again, it just depends on what angle you are going from. As long as you remember how to correctly label based off the angle, then you can figure out any trig ratio. And now this is what we worked our way up to. Using those trig ratios and being able to solve for those trig ratios, we want to be able to solve for problems like this. This is a real world problem that's more realistic of what you guys will see. And it says an 11-foot ramp is installed alongside some steps to provide wheelchair access to a library. The ramp makes an angle of 10 degrees with the ground. Find the height of the wall. We are given the measure of angle A and the length of the hypotenuse. You want to find the length of the leg opposite angle A. So if I look at what I have, they told me I'm given the hypotenuse, and we can clearly see that because going across from angle B, 11 is going to be my hypotenuse. And if I'm going from angle A, because I want to be able to use that 10 degrees, I want to look and see, well, what is it that I'm actually trying to find? And remember, in the problem right here, it says find the height of the wall. In other words, find x. And if you look, that side length x is opposite, if I can draw, there we go, is opposite your angle A, or that 10 degrees. So I have now, I want opposite and hypotenuse. Well, what trig ratio makes that fraction? Is it sine, cosine, or tangent? And we should be thinking to ourselves that it is sine. So I want sine of A equals opposite over hypotenuse, and now replacing values with what I have, I know that A is 10 degrees, so sine of 10 equals opposite was worth x, because that's what I'm trying to find, and the hypotenuse was worth 11. So now trying to solve for this problem, if you notice, I have a fraction of x being divided by 11, and if I'm trying to solve and make x be by itself, then what's the opposite operation of dividing by 11? It's multiplying by 11. Whoops, that was supposed to be an 11. Let me erase that. Multiply by 11. And again, what I do to one side, I have to do to the other. So my 11's cancel, and I'm left with x equals 11 times sine of 10 degrees. And I'm just going to simply plug this into my calculator. I have 11 times sine of 10. And so once I plugged it in, I came up with the wall, or x in other words, is 1.9 feet high. That's a short wall, man. Even Miss Beskar can see over that. But anyways, let me make this a little bit smaller. And now, if they had asked me, how far away is the ramp from the wall, or how far does the ramp extend from the wall? In other words, if I was trying to find y, then what other trig ratio could I set up? So again, I'm trying to find right here y, and again, the only value I have, or the value that they gave me, is angle A is 10 degrees and the hypotenuse is 11. So if I'm trying to find from angle A the adjacent side now, then the question becomes, what trig ratio uses adjacent over hypotenuse? And we should all be telling ourselves that cosine of angle A equals adjacent over hypotenuse. So again, replacing things with what I have, I know that angle A is 10 degrees. I also know that the adjacent side is y, and I know the hypotenuse is 11. So doing the same math as the last time, if I'm dividing by 11, opposite operation is to multiply by 11. And now I can plug this section into my calculator. 11 times cosine of 10 equals, and I get that the distance from the wall to where the ramp extends is 10.8 feet.